transport through the cell membrane, matter and energy unit, video 2. Transport. This is when materials move into and out of the cell through our cell membrane. And we can see different examples of things that move in and out of the cell through this diagram. Passive transport. This refers to the movement across the cell membrane without the expenditure of energy. So there is no energy needed. So we can see in the diagram, outside our cell, our extracellular space, we have a lot of a molecule. So we can say we have a high concentration, whereas inside we have a low concentration. So passive transport would tell us that certain molecules are able to pass from high to low, and that's what they're doing here, until they are equal. We have two types of passive transport. We have diffusion and osmosis. Diffusion. This is the movement of materials from high concentration to areas of lower concentration. And the short form for concentration is square parentheses. And this has caused random molecular collisions. So when collisions occur at a faster rate, diffusion is sped up. So therefore, temperature, concentration, pressure for gases greatly affect the rate of diffusion. So if you increase your temperature, you'll increase your diffusion. You decrease your temperature, you decrease your diffusion. Same goes with your concentration. You increase it, it also increases. You decrease your concentration, your diffusion rate will decrease. So if one increases, the other will increase. One decreases, the other will decrease. Equilibrium is the stable state at which state reached when all acting forces are in balance. So when I have the same amount of concentration on both sides, I'm in equilibrium. Osmosis is our other type of passive transport, and osmosis happens to do with water and how water crosses a selectively permeable membrane. Selectively or semi-permeable membrane allows smaller molecules to pass through but prevents the passage of larger molecules. So water would be the number one, but it's not the only substance that goes through osmosis. Solutions. So we have different types of solutions. So what they are a mixture of a solvent, the universal solvent is water, and solute, which in this case could be sugar. So we have three different types. We have isotonic solutions. So these solutions have a solute concentration that is equal to the solute concentration of the cell. So a really good example would be blood plasma is an isotonic solution for blood. So it's an equilibrium. If any water moves out, water moves in. It's constantly equal. Hypotonic solutions. These solutions have a solute concentration less than the solute concentration of the cell. So water moves into the cell to balance this situation and causes the cell to swell. Okay, so I'm moving into the cell in a hypotonic solution. In a hypertonic solution, the solute concentration is greater than the solute concentration is greater than the solute concentration of the cell. So this is where water moves out of the cell, and this causes the cell to shrink. So water moves out. Active transport. Active transport allows large molecules and substances, or substances occurring in low concentrations, to enter the cell. This is a movement of material from areas of lower concentration to areas of higher concentration. And energy is needed. So this is a big thing. I need ATP. Okay, I need that. 30 to 40% of the energy budget is used for active transport. So we have a low concentration of our purple, and it's moving actively, will move inside the cell. It's actively moving in. So entering the cell. There are different ways we can enter the cell. And one specific way is known as endocytosis. And this is where large particles enter the cell via endocytosis. Endocytosis is a process of the cytoplasm that engulfs large particles and brings them into the cell. There are two types. There is pinocytosis, phagocytosis, and then we don't get much into this in grade 11, but we also have receptor mediation. But again, we have a large particle being engulfed and brought into the cell. So let's look more closely at pinocytosis. This is endocytosis of liquids. Okay? Cells of small intestines absorb fat droplets through pinocytosis. So basically, they're just pinching. So they pinch in, and they have the vesicle, and that's how they bring things into the cell. Phagocytosis is the solid particles are being absorbed. So white blood cells engulf microbes through phagocytosis. So here we have a larger molecule, and it's being engulfed. So your white blood cells are very good at this with microbes. Exiting the cell. We've entered, now we need to be able to exit. Well, exocytosis is a process by which large particles exit the cell. So we have our vesicle, and our vesicle goes up to our cell membrane. It becomes part of the cell membrane, and then it releases its particles into extracellular fluid. Exocytosis. So again, it's large waste particles. They're contained in vesicles, move to the cell membrane. Eventually, the protoplasm streams away from the area, and waste is released.